Alright, welcome back. This is one of the more challenging topics, just because there's a lot to do. The thing you need to remember is when you're taking nth roots of something, like the sixth root of something, that means you need 6 of a number or a letter to pull it out of that root sign to get one whole one back. Just like with square roots, you need a pair inside under the square root to take one of them out. Now with these other ones, you need more than a pair. So it's very important to break down the numbers as much as possible if you can. So let's look and see what we can do with this. Again, we need to keep this simplest radical form unless I state otherwise. So let's use some of our exponent properties to see what we can do. Number one, we have the same base, so we have different exponents. So when you multiply the same base, you add the exponents. Okay? However, we can't add the exponents unless they match. So we have to turn these both into sixths. So 1/2 is the same thing as 3/6 times 7, and then to make this a 6 we multiply by 2, we get 4/6, which is equal to 7 and 7/6. Now, real quick, I want to demonstrate what I'm talking about here. Notice how 7/6 we have a full number 7. Okay, let's pretend I didn't know that. And I have 7 to the 7 sixth root. I'm writing this turns into that. Okay? Well, again, in order to break something out of a radical, you need that many of them underneath the radical symbol. So I need 6 of the 7s in there. So, for example, I have 7. I'm just going to do this real quick because I think doing this once will help you guys. 1, 2, 3, 4, 5, 6, 7. This is basically what that problem is. Now, this is telling me if I have 6 of them, which I do, I can use all 6 of these to bring 1 out, not 6 out, 1 out. So that means my final answer to this problem is 1 7 comes out, and I still am left with a 6th root of 7. And this is now to the first power, or you can just leave it like that. So that is my final answer. Okay, so I hope you guys understand that idea. Now, whenever you're dealing with numbers, it's always good to break the base down to the most simplest term also. Alright, so if you can. 27 can be broken down to 3s. So, first thing I'm going to do is do that. So this is going to be 3 to the 3rd to the 1/3 times 6 to the 1/4 squared. That's the same thing as saying 3 times 6 to the 1/4 squared. Now you can just, because it's multiplication, you can raise both numbers to that power. So this is 3 squared times 6 to the 1/4 squared, which is now 6 to the 1/2. And finally, we can rewrite this as a simplified radical. This turns into 9, and instead of using a fractional, we can say it's the square root of 6. Remember, and if you put a 2 here, that is okay. I don't mind, but for square roots, I assume that it's square root if you do not. Now, you know you're done because look at the 6. 6 breaks down to 3 and 2. There are no pairs to break out. It's just like simplifying a radical. You cannot pull anything out of there. We're done. Okay. Now, next one. Again, you can go in any order you want, but I'm going to simplify the middle first. 4 cubed times 2 cubed. We cannot do, first of all, that is not 8 cubed, everyone. Remember, you cannot just multiply those together. You need the same base. Okay, so let's get the same base. So 4 is the same thing as 2 squared cubed times 2 cubed to the negative 1/3. So this is 2 to the 6th times 2 to the 3rd, or 2 to the 9th to the negative 1/3. Now you can multiply the powers. I get 2 to the negative 9/3, which is negative 3. Again, we do not like negative exponents, so I rewrite this as 1 over 2 to the 3, which can simplify to 1 over 8. Again, always multiply it out at the end. Do not leave it as 2 cubed unless the numbers are really big. Okay? Now here the base number is the same. 6 on top, 6 on the bottom. This is 6 to the 1st over 6 to the 3/4. We used to talk about this as balancing. Okay? You would subtract or cancel what you have. Well, we have to rewrite this top one so we're in fourths because we need to subtract. 1 is the same as 4 over 4. Hopefully you guys are good enough to know that. now I can subtract or cancel. I have 4/4 on top, 3/4 on bottom. I get 6 to the 1/4 on top, which is good, because I do not want that on bottom, because then we have to rationalize, and we'll talk about that in a minute, or maybe on the next page. So we can rewrite this, though. Again, I do not like fractional exponents. I do like this. Okay, the 4th root of 6 is my final answer. Now, again, number 5, if you type this into your calculator, you're going to get a decimal. However, we can break it down more. The key is to figure out how this breaks down. So this is where you do the tree. I know this is 2 times 81. Now 81 is 9 times 9, which is 3, 3, 3, 3. So this turns into the cubed root of all these numbers. 2 times 3 times 3 times 3 times 3. The reason why I do this is, again, if you have, since this is a 3 of an index of 3, we need a triple to pull a number out. Sure enough, I have a triple. I have 3 3s I can use to pull one out. So now I get 3 in front, and I've used these now. And then I'm still left with a 3rd root, and then I'm left with a 2 times 3 or a 6th. And that's my final answer. You can't pull anything else out, but that is it simplified. And again, this is not 3 to the 3rd, it's 3 and then the 3rd root. I should probably, one way you could do that is just put a little line up there and kind of put a number there. So, alright, so 3, 3rd root of 6. Yeah, if you guys like to do that, actually, I don't mind. Put a line so you know it's there. Alright, here, since they are the same, you can multiply them right away and say that we have, remember, when you have square root times square root, you can multiply. If the exponents are the same, here, you can multiply. Okay? So, what do we get? And actually, now I think about that, let me just go back real quick. Up here, on this one, you could have actually multiplied them because they're the same exponent. And you could have gotten 8 to the 3rd to the negative 1/3. It would have worked out the same way. If they were different numbers and different exponents, though, that is when you cannot. So, just an addendum on what I said up there. Down here, you can do the same thing. Same exponent or same root, so you can multiply those together. So this is the same thing as saying the 3rd root of 125. Well, 125 is 5 times 5 times 5. And you can see that here. You can break these down. There's 2 5s here and a 5 there. So when you multiply all those together, you have 5 times 5 times 5 underneath the 3rd root. Well, this is perfect. There are 3 5s to pull one out, and then we have nothing left over. So my answer is 5. This is the one that's challenging. We can't do anything until we break down all the numbers. The other thing that's challenging is we have to keep the same base number for our exponent to simplify it. So let's see what this turns into. I have 10 to the 3/4 is the same thing as 5 to the 3/4 times 2 to the 3/4 times, we can break apart a 6 into 2 to the 1/6 and 3 to the 1/6 all over 5 to the 1/6. Now, in order to make this easier, you need to get all the fractions the same denominator, because then you can put everything under the same radical. Here, I think the best course of action would be to make them a 12th, because that would be the next highest number we can make all these. So if we turn all these into 12ths, to get this to 12, you multiply by 3, so we get 5 to the 9/12. Same thing, this is also 2 to the 9/12. To get 12 here, you multiply by 2, so we get times 2 to the 2/12 times 3 to the 2/12 all over 5 to the 2/12. Now, all you have to do is cancel out what cancels, so the 5s go together. We'll deal with those. And these 2s go together. We can combine those. The 3 is just going to stay by itself. It's a different base. 5 to the 9/12 over 5 to the 2/12. We get 5 to the 7/12. So, I'm going to rewrite that here. I have 5 to the 7/12 with nothing left over because the higher number's on top. I get 2 to the 11/12 because I multiply those out. And 3 to the 2/12. Now, right away you can tell, will I be able to pull anything out of the 12th roots? No, because I don't have enough numbers. My 3, I only have 2 of them. My 2, I only have 11 of them, not 12. And 5, I have 7 of them. So my final answer is that I have the 12th root of 5 to the 7th times 2 to the 11th times 3 squared. Do not multiply that whole thing out. This is a case where leave it as the base numbers because those powers make it a really, really big number. If it's a small number, go for it. Alright. But this is the one that people have challenging with, problems with. So practice things like that, and I'll give you more as we go forward. Same thing with these. Why don't you guys just break it down as much as you can. We have 32. Well, 32 is the same thing as saying 8 times 4, which is the same thing as saying 2 times 2 times 2 times 2 times 2. So, as you get good at this, you'll realize what this breaks down to. This is the same thing as saying 2 to the 5th. And this is the same thing as saying 2 squared. Now that they are the same root and the same base, we can simplify. 2 to the 5th over 2 squared. You get the third root of 2 cubed. Well, guess what? These cancel. We need 3 2's to bring it out, and we do. Okay, 64 is 8 times 8, which is 4 times 2, 4 times 2, which again breaks down to now there are 6 2's. Well, how many 2's can I bring out? I could bring one of them out using 4 of them. So, since this breaks down to 2 times 2 times 2 times 2 times 2 times 2, we can use 4 of them and bring a 2 out. So I have 2 on the outside. I still have the 4th root of 2 squared, or 4. That's my final answer. Okay. Alright. Let's keep going. 49 is 7 times 7, so or 7 squared. And then this is 6th root of it. Now here's another thing that I want to talk about. Even though nothing pulls out, you can simplify this. Because this is the same thing as saying 7 to the 2/6. Well, that's the same thing as saying 7 to the 1/3, or the third root of 7. So you can simplify them if the numbers simplify as a fraction. Okay, that's all we're looking for there. Now, here's the key, everyone. This is the one where you cannot, this is where people have problems. So, this is the same thing as saying the 4th root of 3 on the bottom and the 4th root of 2 on the top. Can we have radical on the bottom? No, we cannot. However, you cannot just multiply by the 4th root of 3, because then you only have 2 of them. How many do we need on the bottom? How many do we need under the 4th root? We need 4 of them. So, I'm going to multiply the top and the bottom by the 4th root of 3 cubed. Now I'm going to get enough to simplify my radical on the bottom. That means I have to do the same thing up here. So what I get down here is I have 3 and 4, so this becomes a 3 on the bottom. Up here I get 3 cubed is 27 times 2, which is 54. And I can't pull anything out because you can already see that there's only 1, 2, and 3 4's, so, or 3 3's. So it's the 4th root of 54 on top. Again, you cannot have a radical on the bottom, and notice that we didn't just do this 4th root of 3 again, because that wouldn't give us enough to cancel out that 4th root. We need 3 more. Alright, let's look at the next thing. I have the 4th root of 7, and this turns into the 4th root of 2 cubed. Well, I'm almost there. I have 3 2's on the bottom, but I can't have 3 2's. I need another one. So I need one more 4th root of 2. The reason why it's only one more is there's 3 there. So I'm going to multiply the top by a 4th root of 2. Since they're the same root, we can multiply them. We get the 4th root of 14. All over, this becomes 2 now. And that is all you can do for that problem. Alright, same thing. This one we're going to break down a bit. 20 goes 5 and 2's, right? This is 5 times 2 times 2. So 5 to the 1/3 times 4 to the 1/3, or 2 to the 2/3. That's what that turns into. 150 is 25 and 6. So we get a 5, a 5, a 3, and a 2. So I have a 2 to the 1/3, I have a 3 to the 1/3, and I have a 5 to the 2/3. So let's multiply everything we need to together. I have a 5 to the 2/3 and 5 to the 1/3. That's 5 to the 3/3, or 5 to the 1. I have a 2 to the 2/3 and 2 to the 1/3. So that's 2 to the 3/3, or 1 again. Well, it's raised to the 1 power. And then I have 3 to the 1/3 that's left alone. Which means that my answer is 5 times 2 and then the 3rd root of 3, which is 10 3rd root of 3. And that's my answer. Again, when you have numbers, break them down all the way. Now, this one is kind of a one that you've seen before. So we can subtract the leading coefficients. So we get 2 to the, or 2 times 4 to the 3/4. Now we can try to put these together. I have 2 to the 1st times 2 to the 6/4, which becomes the same thing as 2 to the 10/4. So my index is 4, which means I need 4 of them. So I have the 4th root, and then 2 times 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 2. I have 2 pairs of 4s, or 4 pair, or I should say a pair of quad 4s. So I can pull a 2 out and a 2 out. So I'm going to say this is 2 times 2 on the outside now, and I'm left with the 4th root of 2 squared. Well, this simplifies a little bit more because we can simplify 2 over 4 into the fraction of square root of 2, so 2. So that's what that turns into. Alright, 2 more. You know, let's save, since this went kind of long, let's save these last 2 for notes in class. I'll talk through them again, just for extra practice. Okay.